So once we finish the process management, we will continue for the thread today. What is a process? Process is the sequence of the instruction also that is loaded into the memory. Then it's ready to be executed by the CPU processor. So we have the different state of the process. Depending on the operating system, it can be various, but mostly it has a 5 state. The first one is the new state, it's just executed. Also, then if that is ready to be executed by the processor, is in the ready state. So also the ready state, the process will be managed by the ready queue. Then the CPU there is a algorithm which is called the CPU scheduler. CPU scheduler will select one of the process based on the criteria. We will learn the details of such a scheduling algorithm later. Okay, and also once it is selected, it's a running state. The running state means that all the information in the PCB will be copied to the register as well as the register. So it will be executed by the process. Once there is an I/O state or something other condition, it can be terminated. So terminate means it's ended. The process then return all the results to the operating system, and the other processes can use such a return the results. Also during the I/O state, it will be changing into the wait status. The wait state, the process cannot do anything. So you can just wait until the I/O device return the data. Then once there is a return data, it will move to ready state. These are the 5 states that we have learned. So this is just the basic of the processes. And also the process can work together, not only just one processor, several processors are working together. That's which is user in operating system. So for that, the cooperation, how can they communicate each other? That is called inter-process communication. So in short, it's called IPC. So operating system provide IPC. How they can support such an inter-process communication using system code. So system library. So if you want to use, so for example, if you want to use such an IPC on your operating system, so you need to check first. So whether what kind of the IPC, the method are provided by your operating system using the system code. So in IPC, there are 2 types of the IPC. One is based on the shared memory. We can allocate the shared memory area, then process can access such area. At that time, you should be careful to get the proper permission. Otherwise, it's very strict. Most of the operating system has to try to protect the memory area by the process. Otherwise, it will be messed up. Another way is using the message passing. Regarding to the message passing, we can implement many different ways. We can use the message queue, or we can implement we can use sometimes the client server environment, such as the socket. So we will see details of such a message passing mechanism today also. So we have seen so we can understand IPC as the producer and consumer problem. So that's the process consumer, the architecture. So today we are going to see such an example of the IPC. Our first one, POSIX. So I think that we have seen one time or a couple of times the POSIX. What is a POSIX? Portable operating system for Unix. So this is a standard, kind of the standard IEEE standard for Unix-based system. So IEEE actually make the standardized. So to make the Unix-based system, this operating system should have this. Among them, the POSIX provide the shared memory IPC, the standard. So in terms of the system core, it is the SHMFD. So you can actually open the shared memory area using permission as well as the size. You can truncate such a size of the memory and so on. Then you can send a message like the writing to shared memory to that shared memory area. At that time, this is one important thing, the FD. FD stands for file descriptor. Actually, in terms of operating system, the understand, recognize most of the device or the data structure as a file. Okay, it's not only for the file that you know, but also, for example, when I'm saying the create a link for the communication, link can be file descriptor. Not only just a file, any data structure can be understood as a file. So shared memory is the same. So when you create the shared memory, it can return the file descriptor. It's the ID. So file descriptor is the ID. So you can find the specific shared memory area using the the shared memory file descriptor. Okay. So this is an example of the IPC using the POSIX standard. So you can see, so we define the size of the memory as the OK, and these are the example of the message. Then this is the SHM that open. So when we open the shared memory area, so it will return the file descriptor ID. So SHM underbar AD. Okay, it has the permission and other. Okay. Then we can create the truncate, usually clear. Okay, assign the specific size. So in this case, it's a 4K size. So we define the size as the 4K, and then we can actually use such a memory area as the shared object. So we can send the message to that and read. From the consumer, we can read such a shared memory. So this is a consumer other process to read. So you can open that part. So you need to appropriate. You need to provide appropriate the permission at the 666. So which means it can be read and write 6, 1, 2, 3, read, write. Permission for all of this. Okay? Otherwise, the other process cannot access such the shared memory. And then you can read the data. Finally, you can unlink. So in the warming up exercise, warming up lab, so if you want to, you can use the shared memory approach for the implementation of the communication. So far, I have only 1 or 2 students who use the shared memory, and many students. But there is a good opportunity to use shared memory for the communication. So what is a mahu? What is a mahu? Any idea? Oh, sorry. Mahu, what is a mahu? It's a microcontroller. Microkernel. So mahu is the microkernel, so such as the Mac OS. So this is what is a microkernel, by the way? It's a microkernel. It's a small kernel. So if we develop the huge kernel, that's also definition of the operating system. Operating system includes everything, okay, including application part. But it's too big to manage. Just in case you need to rebuild, you need to compile everything and rebuild everything. So it's not easy. So nowadays, many of the operating systems pursue such a microkernel architecture. So this is the example of the MAHU, the microkernel, the IPC. So at the time, you can use the message-based. This is a message-based. But nowadays, it's true. Most of the operating systems support both the shared memory-based and message-based, the communication. Okay. So at the time, we create the you can call such a system library to allocate the message. Okay, so you can send a message and receive the message, and the RPC, we will see a little bit more about the RPC later. Okay. So sometimes the message-based approach is called the mailbox because it's kind of in between. So we can consider mailbox as the message box. So you can send a message to that message box. Sometimes you can specify the receiver, or sometimes not. Okay. Then the receiver will check the mailbox, and if there is any message, and take it. Okay. If the receiver is specified, only in case matched, the receiver can take the message, consume that message, then they can communicate. Windows also provide the message-based the IPC, which is called LPC, local procedure call. Through the local procedure call, you can, so it's kind of the mailbox approach. So we can call such a mailbox as the port. So using the port, we can establish the link. Okay, then it's that establish the link called as a channel. So after we make the channel, the process can communicate using the message. Okay. We will see a little bit details about such a communication port and the link in the socket later. Okay. So this slide shows the IPC using the LPC on the Windows. So client means it's client is a two process. One is called the client who requests the communication, and there is a request communication. Then using the USB port and create the channel. Okay. Then after it's established, the server and client they can share the something object. Okay. It should be less than 256 bytes. It's kind of the size of the packet. The more popular the communication method is client-server environment. So that includes the socket, limit procedure call, it's the IPC, okay, and pipe, and in Java it's the RMI. So if you took the Java programming class, suppose you learned about the RMI. So I'm going to just explain the high level, the concept of the RMI. Because the Java is based on the virtual machine, that is the main process. So you need to make some communication, the common area for the communication, that is called the RMI. So first the socket. So socket, if you are taking the network courses, you probably, I think it's an early project usually in the network class to practice the network programming. So usually that is based on the socket. Why don't you think about the web service? So when you connect the web browser, so what do you type on your address? HTTP semicolon / and the address. Okay? Then what does that mean? HTTP. Actually, it's not only for the address, URL address for the web service. If we are using any TCP/IP based application, you use the same format. First, this is protocol. Okay, HTTP means I'm going to use HTTP protocol. Okay, what is a protocol? Set of rules for what? Communication. Okay, so most of the communication is between at least the two process, two server, to the object. Okay, they should share the rules, or they should have something common, the idea. So that is the protocol. So in network protocol, so you probably done the OSI layer, and so first low level is the hardware, and to the application layer. Okay, so this is a protocol. So which means I'm going to use the HTTP, or sometimes HTTPS. That is secure HTTP, something like that. Then we have the address. It's a Actually, the bridgeport.edu, this will be converted to IP address. Okay? By what?
Yes.
Domain. Name server, so IP address. 168.1.1.2, something like that. And actually it has something other number. It's a port number. The HTTP use usually 80. Okay. Can I use other port number for the HTTP? Yes, if you want, you can use the 10,000 port number. But at that time, you need to specify that number from the client. Okay? This one is well-known. This is called a well-known port number, like the 80 for HTTP and 23 for FTP, 22, 23 for FTP, and something like that. The ping is for what? Ping. I cannot remember all of this, but it has the well-known. In case of well-known number, you don't have to specify it. Otherwise, so which means server computer is kind of the house. So to go to that house, you should know the address, IP, and specific door. Sometimes it has many doors. So this is a port number, and you should specify how to go there. It's a protocol. You should specify these three. So any socket-based client-server environment, if you know that these three, the protocol, port number, and IP address, you can actually access the data. Database is the same. I'm teaching the database course also. From the database client to access the server, which means the database server. So I need to know whether this is a TCP/IP protocol or UDP protocol or other protocol TCP, and the IP address or the domain server name, and also plus the port number. Database use their own port number, then I can connect the database. So it's the same thing. That is a socket based on the socket. So to connect such a communication link, we should know the port number, IP address, and port number. Time. Usually 127.0.0.1 is my set, the loopback, the IP address. Then we can make the connection. So this diagram, there are two types of the socket program. One is connection oriented. Another one is connectionless. Connection oriented means so you and me acknowledge the connection, and first, before we send the message, we can make the connection. Okay? Then we guarantee to send and receive the data. On the other hand, connectionless means we can keep sending the package. I keep sending, whether or not my girlfriend received my mail, I keep sending. Sometimes it's the express mail, arrived earlier than the other. Doesn't matter. It's a keep sending. Sometimes it lose, we don't care. Okay? That's the difference. So connection is TCP. Okay? The TCP protocol is considered as the connection oriented, and connectionless is UDP. Okay? That is the main difference. So that is the reason. Nowadays the network environment is getting better, though we don't have to worry about too much. But several years ago, so when I watched the video, live video stream, so from Windows player, Windows Media Player, I can select UDP rather than the TCP, right? Because the UDP keeps sending. Sometimes I lose the packet or slow, but it doesn't matter, keep sending. So I can keep receive the data. So sometimes a little bit the noise, but I can keep displaying. However, TCP, if I lose something data, is something problem, so keep trying to receive. So it takes a little bit time. So that is the difference between the connection-oriented and the connectionless. So this one, you can see the connection establishment, then the request the data, and the reply the data between client and server. That is the connection-oriented protocol. That is a TCP. On the other hand, the connectionless protocol is a UDP, which is called the UDP. They just sending using the. However, the basic mechanism of the sending the packet is the same. Just the sending using the TCP, the IP, and the port number. You can just send the data, but you cannot guarantee whether that packet, that message is delivered. Okay, because it's not connection is not established. So for each case, sometimes this data can be lost. So we can use such a socket communication for actually many. Okay, so this is an example of what? Web server. Server-side program in this case. So for example, if we are using the socket, this is a server. Server-side program of the web interface is what? It's the process that is HTTPD process. You can see actually. Why don't you? If you start up the web server like the Apache web server, so after you start, why don't you check your process list using the command? You can see sometimes many process. D stands for it's a daemon process. Daemon process. What is a daemon process? It's kind of service program. Even though you log out, so I start the Apache web server. So if there are many, the HTTPD. Who is the parent? Actually, me is the parent. Which means when I log out, when I kill myself, which means the children process will be killed, terminated automatically. Okay, it's a cascade terminated that we learned before. So, which means I should log on every time 24/7, right? So it's not good. So we can make such a process as a daemon. When we make the process as a daemon, which means the parent-ship relationship is disconnected and the operating system will take over to control such a process. Then this service program keep running even though parent process is lower. There's no parent relationship. So then to connect this one, the client. Usually client module is what? Web browser. Okay, you can use a web browser, or even sometimes you can use other application like for example wget. Anyone who use the wget? When you get the file, okay? At that time you can use the HTTP protocol. You can use the same address as the HTTP / whatever, then file name. You can get the data using same the socket communication. Okay. So but mostly client is a web browser. Web browser you can when you type it. So actually .edu index.html file. So I need HTML request that data using that information. So this server side program, socket program, retrieve that file and return to here. So this HTML file has tag information, right? H1 or the P or the HTML, something like that. And so this tag information will be translated, okay? Because they follow the standard, the HTML standard 1, 2, nowadays. So 5, support what? Flexibility of the in terms of resolution. Because this one is too small, so if we browse, so that is a reason actually when you request this one, it's not only the file information, but a lot of information sent to the server, source information. That is the reason HTTP is not safe. So at the time, if you want to encrypt, you can use the HTTPS. Even that can be decrypted. So that is the reason over the internet, if somebody can check the traffic, so your credit card information can be viewed. Others, anyway, that's different story. But so a lot of information is sent. So that information can be used logged in the server side also. Okay. Then based on the operating system of the client, it can return the mobile, the HTML, or the regular full site HTML differently. However, in HTML5, they consider resolution of the device. Okay, what's the size of the display and adjust based on what? They consider relative size. Okay, for example, table. So table, you can specify the width of the table, and so it can be adjusted. That is the HTML dynamic, something I forgot the name of that. So that is the socket. The program, it can be used not only for the HTML, but it can be used for FTP, file transfer. File transfer, use the FTP daemon, so it will return. So FTP client, if you log in, so you can put the file or get the file transfer. Okay. But basically it's the same mechanism, but different application. So this is the example of the socket program in Java. So this you can see. So you can create a socket using the specific port number. Okay. Then the client. You can define the client. Okay. You can list after you created the socket. So now this is listening. Okay. How many? 1, 2, 3, 4, 5. It's very simple. So why don't you try? This one is for the day server, which means the client request. Once the client make the request something, it will return the current date. The next one is RPC, remote procedure code. Remote procedure code is between the server. We can consider IPC as the internet environment, but still it can be used in the, actually it was developed within one server, it's the same server. But sometimes we have the different server, A, server B, so we'd like to run the program in other server remotely. At that time, IPC, the remote procedural code interface was developed, especially for remote. The execute the application remotely. Okay, RPC. Okay. So this slide shows the step by step of the RPC. So this one can be considered the client and server side. Okay. So actually, in server side there is the client side. First, client side is called the stuff. Stuff is the it's kind of the proxy. Client side the proxy to execute the server side. Server side the procedure. Okay. Server side the procedure, and let's see this one. Once, so even though it starts from the process, but this process does not directly connect to the other process, unlike the IPC, the socket program. Actually, kernel send. Kernel is in charge of both sides. The kernel is in charge of the communication. Okay, so kernel send the message to the server side, the matchmaker. Matchmaker receive the message and assign the specific port for that request. Then let the client side know. Then finally connection is established. That is the difference between the socket program and RPC. RPC, such a server side, the kernel is involved to make the connection. Then send the name of the procedure, then decide server side, execute the procedure, and return code or return message will be returned to the client side. So For example, in Unix, you probably see RCP command. What is a CP command? It's a copy the file. So if you add RCP, which is based on the RPC procedure, so remotely you can copy the file. To do that, you cannot directly use it in any operating system. You need to set up, configure your environment. Whether in the unit is dot allow file, in the etc / dot allow file, you need to put the remote sign, the server name and IP address to allow the RPC. Nowadays, the administrator actually do not like the using RPC because of the security reason. If you allow RPC, which means somebody can execute the my program. Okay? There can be security hole. So most of the operating system, most of the administrator, they block such a remote procedure code. So nowadays, not many use. It's not very secure. Next one is the pipe. Pipe is a very interesting data structure and communication method. So let me show one of the examples. So pipe is, what is a pipe, by the way? Pipe is, it's kind of cube, right? Pipe is pipe, but it's kind of cube. It's you can send a data and somebody can receive the data, which means you can communicate using such a cube like the data structure, which is called a pipe. But you already have seen the pipe structure. I don't know what happened, the virtual machine. So, for example, so what is the ls command in Unix? It's the list the file. So it will list all the file. So suppose that I have the 100 file. So it will be quickly the scroll up. So how can you check all the file one by one, screen by screen? At the time you can use bar and another command more. This is called pipe. So actually I learned two commands, two processes. One is ls application, one command, one process. Another one is more command. More command actually, if you type the more, then a.out file, which means it's a show screen by screen. Okay? You can use the space bar to move to another screen, scroll up, scroll up. So this time, if I use the pipe, then output of this command will be input of this one. Okay? So two processes can communicate. So this is the communication using pipe. Okay, let me see whether. So then, for example, if I type ls minus a is too many, it's a scroll up, so I cannot see it. So why don't you using more pipe and more, then you can see the more command is executing after this one. But it's the same time, but send the output of the first command to the second command, the second process. So two processes can communicate using the pipe. Then this is So if I do not use, so for example, more, this is just the display, run the one command, more command. So it can show the page by page, okay? Or if you enter this one. So you can combine two commands. Actually not combine, two processes are executed same time, then communicate serially. That is the Pi. So we will see that. Right? Okay. So this one has the parent and child because it has the input. It has the kind of output, end of pipe. So end of pipe and connected to the child. Okay, so kind of parent and child relationship. Okay. So the normal pipe is specified to the child destination. Okay, which means the third party, the other process cannot access the data. Unlike the socket. Socket, as long as you know the IP address and port number, you can connect to the server and communicate, receive the data. Unlike however, the pipe does not allow it. However, if you specify the name of the pipe, which is called the named pipe, then as long as the process, child process, know the name of the pipe, you can connect the pipe and get the data. So that is the pipe. So this slide shows you can see the parent and child. So if you allow only one direction, so which means parent only send the data and child only receive getting the data. That is the one direction. But if you want to establish the bi-directional, you can create the even from the child side, you can specify the pipe. Okay, then it can be bi-directional like this. Okay. So name the pipe. So you can, when you create the pipe data structure communication, you can specify the name, the file descriptor. Then it can be used for other process as long as it has the permission as well as the name, knowing the name. Okay? There's no parent and child relationship. Okay? Also, this is the named pipe is usually the bi-directional, which means that any process that knows the name of pipe, it can provide the data and receive the data also. Okay? So that's the end of the chapter 3, the process management. So once we finish the process management, you can complete the warming up exercise. So exercise lab. In the warming up exercise lab, you should be able to create a process and processes. Okay? Then establish the communication link and communicate. Implementing the algorithm is not very complicated. It's just rock, paper, and scissors. You don't have to move. Many of the students actually spend a lot of time for graphical user interface and nice figure. But first thing is that you need to properly establish the link and communicate. But I'm not going to allow to use the virtual machine itself if you are using the Java program. So at that time you need to create the child process as a separate the virtual machine. Okay? So at that time you can use the runtime the object that has the execution, exec, the method. Okay. Then that is an individual project. That's for as I named it. It's not the main project. It's the warming up. So because you had a winter break and this month, so it can be a good opportunity to. Also, if you believe that you don't have enough the programming skill, this is a good time to skip up for such a program. Okay. The next thread. We have already talked about the thread. Nowadays, the concept of thread is getting important because many of the virtual machine-based the operating system use such a concept of thread a lot. So we will see what is a thread and how we can implement it. before that, I think there might be the typo on the class website for regarding to the midterm exam. When is the spring break? When is the spring break? March, the third week, right? It was the fourth week, the last year. Anyone who was here last spring? No, nobody? Yes. Last year, the spring break was weird a little bit, right?
Yes.
Did you realize that?
Yeah, 18
So,
to 20.
yeah, it's the fourth week, almost the end of the March, which I didn't realize. Because of that, I actually set up the wrong schedule for engineering 400. I invite the speaker during the winter break, spring break. So we worked hard to actually ask the PhD student attend. But anyway, so this time it will be the third week. So we will have the midterm exam 1 week before. So during the midterm exam week, but there is no specific schedule. We will follow the same schedule as the class hour, which means we will have the exam 3 o'clock to the 4:15. But I'd like to discuss about the date of the midterm exam. So we have the 10 and 12. Okay, it was marked as the 17 because it's a typo. So either 10 or 12. Which one is better?
12.
Right? I'm thinking because it's a weird spring, we have a lot of snowy day. Okay, snowy days. So I'd like to use one of the day in case we have another cancelled class. But I'd like to make up first online the tool like the BB Collaborate. So, but I'd like to decide the midterm because I have a couple of students who want to know the date of the exam for the spring break, the schedule. So unless there's a further snow, I'd like to have the exam March 10. Okay? Because many of the midterm exam is on Thursday or the second day of the week. So, but in case I have any specific reason to have the Thursday, another exam on advanced database, that's my class.
Yeah, it's on Tuesday, right?
No, that should be. Oh, that's also Tuesday, I think. Yes.
It's better one should be on Tuesday, one should be on Thursday.
We are undergrads. We have 6 exams anyway. Doesn't
So
matter.
this is what I'm thinking. So I'd like to have the exam on Tuesday, okay? Because I have an invited speaker the Thursday at the time. So I'd like to have the exercise lab on Thursday. That is the reason I switched to that. Okay, and also the Thursday, because of that invited speaker, unless there's a further snow, so I'd like to have the exam on Tuesday, then focus on the invited speaker. Any other opinion? So, in case we have, unless there's a further severe snowstorm, so we will have the Tuesday exam. But in case we need a makeup date, so I will shift to the Thursday. Okay. Regarding to the exam, probably we will have a time to. It's chapter 1 through 6. Even though I'm going to cover the chapter 7 up to the chapter 7, so it's the chapter 1 through the 6, and also probably I will have the review time, 10 to 20 minute review time before the exam. Most of the recent core is from the public school or the cancel delay. So many. So regarding to the midterm exam, in case either probably I will have the review time. airplane mode. By the way, I'm using today I'd like to change the cell phone plan to third party. I'm using T-Mobile, but today I'm going to change it. Have you ever heard about the Ultra-Me? No? Ultra-Me? Yes, so very cheap and reliable. It's only $20 for unlimited text, unlimited. I think Ultra-Me use the AT&T, right?
Yes, sir.
Yeah, it's the same. The coverage and same thing. I didn't realize that, and my daughter actually asked me the unlimited. So no, you cannot use unlimited. Then she bring that plan. One of her friends use it. It's $20 that has the unlimited text, unlimited call, and the 100 megabyte. But if you pay $5, then it will be increased. Also, one of the good thing is from time to time I need to call international, my hometown, but many of the country are free for international call from cell phone. Really. Anyway, so today, I'm going to change. Okay, so this is the final one. So we will have the midterm exam on Tuesday, the March 10th, and the same time as the press hour. It will cover the chapter 1 through chapter 6. So I will have the review time to review the chapter 1 through 6. Even though I covered up to the 7, the midterm will cover the chapter 6. And then the thread. Okay. I think that we have talked about the thread before. Do you remember that? Because you're sitting in front. Who called you? You come in because of the attendance check, right? Who texted him? I will give you the extra point. Okay? Anyway, what is the thread? If you can answer, I will give the attendance. Otherwise, you are next. I believe you attended before, right? Really? So thread is the sequence of what? Process. Process? No. No. It's an instruction. Okay? Anyway, so if you open, I'm not sure whether how you guys can open the program. If you open, it has series of the instruction. This series of instruction will be executed very quickly. It looks like the thread of your string. Okay? Then actually the one CPU can handle one thread at a certain time. Okay? But to support multitasking, we can slice. We cannot increase the CPU time. CPU time is time. Okay? It's just one time. But we can slice and increase the utilization 100%. 100% utilization is not good for the performance. Okay? So 100 utilization means there is no time to be used for management or the other interface. So you should less than the 100%. But anyway, our goal is ideally to maximize the CPU time. But if the process only one thread, which means one program. So think about our MS Word. So if I run this program, this is one program. So this one has the when I type, this one, why this time it doesn't show any underline? Spelling check is on, disable. I'd like to show the spelling checker. I don't know what happened. Okay, so you can see, okay. So this is automatic adjustment, right? It should be capital letter or something like that. While you are typing something, so there are other services running on this, even one program, the MS Word. So which means the CPU need to schedule, typing, the displaying, the spelling checker, and others. Okay, it takes longer. What if sometimes? So why don't we consider in your MS Word program, this part is a spelling checker, this part is a display, this part is the input, and this part is the formatting. Okay, consider several parts of the process. Okay. However, if you create a different process need what? Code, text, what else? The heap, and set, and all the component required for the process. This one has the same process. So it's a waste of your research. Many of them, all of them are in the Microsoft Word. They share the same code but different module, right? So can we make the separate data structure?